Thank you so much for joining this lesson. We shall be discussing paper 1, section 2. Therefore, in this paper, we're going directly to the section 2. And I hope that you guys are going to get a lot from today's discussion. It's good for you to remember that our consultation line is 0704 15 3333. So that is our number, 3366. You can reach out anytime through WhatsApp for any consultations on mathematics and physics. Look at number 17. A group of people planned to contribute equally towards a water project which needed 2 million Kenya shillings to complete. However, 40 members of the group withdrew from the project. As a result, each of the remaining members was to contribute 2,500 Kenya shillings more. Part A, find the original number of members in the group. So this is where we will start from. Getting to the information, we're supposed to analyze a few things. For example, this whole project required exactly 2 million Kenya shillings for it to be started and completed. Then the members who are in this group now, just before they actualized their plan, 40 of them withdrew. After they withdrew, it means now the remaining ones have to top up so that they compensate and have their total of 2 million still actualized, even they are now few. Therefore, we're supposed to come up with the original amount that would have been contributed per member. So original contribution per member, original per member. So for us to get the original amount that would have been contributed per member, we need to take the total 2 million and we divide it by the original number of members, which we can assume to have been X members. So total amount that we need divided by or shared amongst the X total members, that would have been giving us the original amount of money that a member would have contributed initially. Then that means now after the withdrawal of 40 members, we have the new amount per member. The new amount per member is going to be, remember, they are still going to raise the 2 million, though they are fewer now. So they are now total X minus the 40 who withdrew that way. So this is the new expression for the total amount that will be given now by the remaining number per head. Then now we can say the original amount is smaller per person. The new amount per person is now greater. Therefore, when we take the new amount that they are giving now, this is the new amount they are giving, minus what they would have given before the withdrawal of some of them, then we're supposed to get the 2,500. So this gives us now the amount of money that an individual, okay, the difference, this expression for the difference, and we've already been informed so that they were to give 2,500 more than how they would have given initially. So this is now the equation that will lead us to solving the value of X. Remember, we are finding the original number of members in the group. That means what we are getting here is now our answer. Let's find X. We can first start with the LCM in this case. Let's look at this. I'm treating it like any fraction. X minus 40 into X times 1, which is just X. So LCM divided by the first denominator, we remain with X. So 2 million X minus, we divide again, LCM divided by the second denominator, which is X. So we remain with X minus 40. So 2 million into x minus 40. This is equivalent to, we divide LCM by the last denominator there, which is just 1, and the LCM shall remain just as it is. So 2500 into x squared plus 40x. That's a minus, sorry. Should be careful with signposts. Very careful. Yeah, that way. At this point now, we can drop the LCM, then we open brackets and later group terms together. So I proceed to that stage now, whereby I'm having 2 million x minus 2 million x. Then this becomes positive of 80 million. 80 million. Is that 80 million? That way? Yeah, it should be 80 million when you consider the number of zeros there. 80 million like that. Then this is equal to 2500. X is now squared minus, when we multiply 2500, 2500 multiplied by by 40. Let me use my calculator at that point. Let me just use my calculator to multiply 2500 by 40. That gives us 100,000. Yeah, 100,000 x. That way. If we start grouping terms together, I will have 2 million x minus 2 million x. That one cancels. Then we can have our equation now, starting with 2500 x squared minus 100,000 x. Then the 80 million also becomes negative on the other side, like that. Then we remain with 0. So with this equation now, we can group terms together. Okay, we can simplify where possible, so that now we solve the equation. To simplify this, we can divide through by, when we divide by 100, or we can divide through by, 2500, I think. Yeah, we divide through by 2500. So when we divide through by 2500, ladies and gentlemen, then we shall have x squared, then plus 40. No, these are minus, sorry. Minus 40 x, then plus, we divide 80 million by 2500 and we get minus, is it a plus or a minus? For my case, it's a minus. It's still a minus. Minus 3200 or 32,000 equals to 0. Then now we are supposed to solve this one. To solve this one, we can talk of, is it 200 and 160? 200 and 160, yeah. 200 and 160. So with 200 and 160, we need a product of negative 3200 and a sum of negative 40. So when we talk about negative 200 and 160, that way, yeah, the product is negative 3200, the sum negative 40. So now this is x squared minus 200, sorry, minus 200x, let me write 12, minus 200x positive 160x minus 3200 equals to 0. So from the first two terms, we factor out x minus 200, then plus 160, we remain with x minus 200. This is equal to 0. From the brackets, we are having x minus 200. And outside the brackets, we have x plus 160. This is all equal to 0. So now from the first factors, we can say that x minus 200 equals to 0, meaning that x is 200. Or from the second bracket, x equals to negative 160. And because we are handling a number of people, then the original number is supposed to be 200 people, because a given number of people cannot be negative. So we stand with 200. So that is how we solve that particular equation. A very good example. Remember to subscribe to this platform. Remember also to share the link so that you may invite a friend. We are proceeding to part B as I invite you to our programs here for the candidates 2025 and the years to come. We have weekend programs here whereby you enroll with only 200. Remember, our consultation line is already attached there. You can consult more about our programs. We're going to have the classes on Google Meet. Google Meet is a very interactive forum whereby you get to ask questions, you get to answer to questions, you get to seek clarity, you interact one-on-one. It's just like an ordinary classroom. So feel much invited to enroll to our programs. To those who are continuing students, we have the one-term ahead program here, whereby from the 20th of November to 12th December, we shall be covering 2026 term 1 work in advance, so that by the time you are going to your next level, you will be having the content right with you. Yeah, the content right with you. So we have grade 7, 8, and 9, then Form 3s and Form 4s of next year. Please feel much invited. Enroll to our program. See you in Shifting Grades Online School. Through Google Meets, we shall make it happen. So thank you so much for being part of this. Now we are in part B of the first question. 45% of the value of the project was funded by the Constituency Development Fund, that's the CDF. Calculate the amount that would be made by each of the remaining members of the group. So now we say original number is 200, therefore remaining number is 160 because 40 withdrew. Now we are told that 45%, so 45% of 2 million is being funded by the CDF. I'm just thinking out very fast. Instead of calculating the 45% that was funded by the CDF, we can directly calculate the 55% that will have to be given now by the members. So the 55% of 2 million is what will be contributed directly now by the members. 55 out of 100 by 2 million. And this gives us 1,100,000. This is what will be contributed by 160 members who remained. Therefore, each member shall give, and we take the total amount to be contributed, and we divide by the number of people who will contribute. Then we shall get the amount from each individual. This is going to be 68.75. 68.75 Kenya shillings. So that is the amount per individual according to this project. So that's how it would work. Very simple. Very simple. Part C of this. Members' contribution were in terms of labor provided and money contributed. The ratio of the value of labor to the money contributed was 6:19. Calculate the total amount of money contributed by the members. So we'll say that the the ratio of value of labor to the money contributed. That means money contributed takes 19 proportions. So the money contributed is 19 out of the total proportions, which is 25 according to the ratio there. 6 is to 19. Then we multiply by the total amount they were to give. You either participate to give labor or you give the cash. So the money that they would give is going to be 836,000 Kenya shillings. So that is the amount each. Okay, the total amount that they gave is money. The other part became labor. I hope you understand that language now when it comes to constructions. So that is it. Number one on quadratic equations and expressions. You can be required to construct or to come up with quadratic equations and you solve them in real life situations. So that is it. Very simple. That's why I keep advising learners to always know how to solve quadratic equations and expressions together with simultaneous equations and expressions. There are very many topics that require the application of those particular topics. Therefore, make sure that you are very conversant in solving such equations. Given that the matrix A equals to 3, 4, 2, 3, find the inverse of A. For us to get the inverse of a matrix, we're supposed to find the determinant first. So the determinant of this matrix shall be 3 by 3, that is the product of the elements in the leading diagonal, minus 4 by 2, the product of the elements in the other diagonal. Therefore, I'm getting 1 as the determinant. So I'm supposed to divide every element by the determinant. Then for me to get the inverse of A, there are a few things that I'm supposed to interchange. One, the position of the elements in the leading diagonal. So 3 is supposed to change position with 3. Coincidentally, the two elements in the main diagonal are 3. Therefore, if the two elements are 3, I want you to know that I have interchanged the positions of the 3. So the 3 you see on the first position is different from the 3 appearing in the last position now. They have changed positions. I want to emphasize this so that students do not confuse by thinking that I have not done anything on the leading diagonal. It's just a coincidence. It's just a coincidence that the elements in that particular diagonal are just the same. So I have switched their positions. The 3s have changed their respective positions. Then for the other 2 elements in the other diagonal, I changed their signs. This becomes a -4 if it was 4. This was 2, now it becomes a -2. If they were negatives, they would have become positives. So that's how you do. Then when we divide by the determinant, which is just 1, each element remains the way it is. So we don't have to struggle so much dividing by 1. So we are supposed again to divide by the determinant. Just an emphasis so that again, students may not think I have not done anything. I have divided everything by 1. And by dividing by 1, everything remains the way it is. Look at part B of this wonderful question. Are 2 schools, A and B, purchased beans and rice? School A bought 60 bags of beans and 80 bags of rice for a total of 240,000 Kenya shillings. School B bought 150 bags of beans and 225 bags of rice for a total of 637,500 Kenya shillings. Use matrix method to find the price of 1 bag of each item. So we're going to come up with linear equations first and say 60 bags of beans. So 60, assuming that each bag of beans is sold at X, then plus 80 bags of rice, each bag is sold at Y. This gave us 240,000 Kenya shillings. Then the other school, we give equation 1 to this. The other school now, which is school B, 150 of beans by X. The other one, 225 at Y each bag of rice at Y. This now led to a total of 637,500. Yeah, that gave us 637,500. Okay. So at this point now, we can simplify the equations. The first one can divide through by 20. When you divide by 20, you're going to get, when you divide the first one by 20, we get 3x. Yeah, we get 3x plus 4y equals to 120. Okay, 1200 because we're dividing by 20. So 10 cancels like that. The second equation, we can divide it by a common multiple like 75 so that we get 2b or 2x plus, when you divide this, you directly get 3 times y, and this is giving us 2500 that way. So we have the linear equations simplified. How do we proceed to solve using the matrix method? Now we extract a matrix equation. For you to extract a matrix equation, this matrix equation is supposed to be having 3 matrices. The first matrix is called the coefficients matrix, whereby you extract the coefficients as 3, 4, 2, 3, like that. Then what else does it have? What we call the coefficients matrix. Those are coefficients matrix, sorry. Then the variables, x and y, variables matrix. This is equal to, the other one now is a constants matrix. Constants matrix. So we have a constant matrix like that. Therefore, how do we solve now? We have the matrix equation extracted. Coefficients matrix, variables matrix, constant matrix already extracted very well. Now, to proceed from this point, we need to talk about multiplying, pre-multiplying actually, both sides of this matrix equation by the inverse of the coefficients matrix. So the inverse of the coefficients matrix, when you look at it well, it resembles the matrix A that we add here. Therefore, the inverse of this matrix has already been found. 3, -4, 3, -4, -2, 3. We already found the inverse like that. Then we multiply this side. This is equal to 3, -4, -2, 3 times 12,000. 2500, like that. Looking at this now, you discover that we've pre-multiplied both sides of the matrix equation by the inverse of the coefficients matrix. There are a few things that we're supposed to know about matrices. One is that when a matrix is multiplied by its inverse, we usually get the identity matrix. What is the identity matrix? A matrix with 1 in the leading diagonal and zeros elsewhere. So that's how the matrix looks like. So this matrix times this one, a matrix and its own inverse, we get the identity matrix. Then xy equals to, we can perform some multiplication on the right-hand side now. Remember, to multiply matrices, we need row times column. So 3 into 12,000 minus 4 into 2500. This gives us 26,000. Then -2 into 12,000 plus 3 into 2500. I'm still very careful on that to ensure that I'm multiplying the right thing. To ensure that I multiply the right thing, that particular point. Just give it a minute because we can't get negative cash, ladies and gentlemen. There is no way we can get negative cash. So at this point, we should be having, let me just check. In this equation, when we divided by 75, 637, 500 divided by 75, that should have given us 8500. So at this point, this is 8500, 8500, meaning that we are multiplying here by 8500. Yeah, that way, 8500. So now when we perform this multiplication, we can check. Let's check as we get the new answer now. 3 into 120,000, then negative 4 into 8500. This becomes exactly 2,000, yeah? Then negative 2 into 120,000, then plus 3 into 8500. This becomes 1500. So now at this point, we can say identity matrix multiplied by any matrix, the matrix remains as it is. If the matrix remains, then we say XY remains. Then on the other side, we have 2,000, 1,500. So X, which is the beans price, then Y, which is the rice. This is rice per kilogram, okay, per bag, and this is beans. Yeah, that is beans. So we have solved the equation using the matrix method. Part B, okay, that was part B, okay. So we check part C of the same equation. The price of the price of beans later decreased in the ratio of 4:5, while the price of rice increased by 20%. A businessman bought 20 bags of beans and 30 bags of rice. How much did he pay? So the price is 4/5. That's a decrease of beans. Then what we get here, we multiply by 20 bags. Then again, okay, how much did he pay? So we can talk about adding. The other one is increasing by 20%. So it became 120% of the original. And how many bags are we buying? The man is buying 30 of them. This shall be 4/5. This multiplies to 1,000. Then 20 bags. This is 32,000. Then we add 120% times 1500 times 30. This gives us 54,000. Therefore, we shall have a total when we add 3200 and we get 86,000 Kenya shillings. 86,000 Kenya shillings. That is what this gentleman paid for the purchase. Very interesting question. Number 19 now, on a velocity time graph for a car. We can see the velocity time graph, right? Find the maximum speed attained if the distance traveled is 1,600 meters. This is a very interesting question. There is something that we're supposed to understand when it comes to this, that area under the graph, when it is a velocity time graph, gives us the distance. Therefore, the shape is a trapezium. If we assume that the total is x there, the height covered there, that is the maximum velocity attained, it should give us the height in this case. Therefore, we say the total distance should be given by area of the trapezoidal shape, which is half into the two parallel sides, whereby the first side is having 25 from 0 to 25, then the other one from 5 to 20. Is that okay? From 5 to 20 is 15 units. Yeah, 15 units. Then now we will talk about times the vertical height between them, which is just x. Therefore, 16 0, 0 equals to 40, I think 40, yeah, times half, 20, 20x. So at that point now, we can remain with x, whereby we divide through by 20, giving us 80 meters per second. Yeah, so that is 80 meters per second as the maximum attained height, maximum attained velocity or speed. Part two of this. The question says that we calculate the distance traveled in the last 5 seconds. The last 5 seconds. Remember, we are having 80 as the maximum speed. Then now this is the last 5. Therefore, it's area of a triangle. Area under the graph should give us distance covered. Therefore, the distance shall be half times the height of 80 times distance of 5. Like that. This will give us 200 meters as the distance covered in the last 5 seconds. Part B, determine the retardation in the last 5. Retardation is supposed to be, this can be done in 2 different opinions. First, we can talk about the gradient of this part. We are moving all the way from 2080, that's the coordinate, all the way to 25, 0. Yeah. 2080 all the way to 25, 0. So we get the slope at that point. The slope will be change in y, 0 minus 80 over change in x, 25 minus 20. This shall be negative 80 over 5. Now, when you divide negative 80 over 5, we are getting negative 16, meaning that this is negative 16 meters per second squared. That's our acceleration. So a negative acceleration means a deceleration of 16 meters per second squared. In other words, deceleration is the absolute value of a negative acceleration. Deceleration is the absolute value of a negative acceleration. Okay. That way, that is the retardation. Again, retardation can be given by, you can say acceleration equals to final minus initial out of time. So a final speed of 0 from an initial of 80 within the time taken, which is 5. So we are getting the same acceleration. We're just getting the same acceleration without applying the gradient method. Without the gradient method, we are getting the same figures. Meters per second squared. Then there is the last part, the very last part in this, in part D. In part D now, what are we supposed to do? Find the average speed for the whole journey. How do we get average speed? Basically, average speed is total distance. Total distance out of total time taken. The distance of 1600 that we are given here is covered within 25 seconds. Therefore, we take total distance covered out of the total time taken, and this is going to give us exactly 60 meters per second. Yeah, 60 meters per second. So that is how we work out the question on linear motion. Very good question. Very good question. We check number 20. Yeah. Let's check number 20 now. The histogram below represents the number of students in 40 schools in a certain zone. 40 schools in a certain zone. Now look at what we are told now to find. We can see the histogram, and from the histogram, what we can see is that frequency density has been plotted on the vertical axis, and that explains why the class intervals are not uniform. You can see thicker classes than others. Yeah, thicker classes than others can be witnessed in this case. So part A, starting with a class of 100 to 200, develop a frequency distribution table from the histogram. What you're supposed to know is that we use class boundaries and frequency density when the class intervals are the same. And frequency density is usually calculated by frequency out of class length, frequency over class length, meaning that from this, frequency can be claimed back by multiplying class length times frequency densities. Yeah, class length times frequency densities. So what we have here are boundaries. If the boundaries in the first class is from 100, let me write class. I think I should have something well designed. Let me design my table properly. So we have the classes here from 100 all the way to 200. That is the first class. Then what will be the respective frequency there? We take the class length of 100 from 100 to 200, 100, and we multiply by 0.04 times 100. That's giving us a frequency of 4, right? Yeah, a frequency of 4. Then we proceed to the next class, whereby we are starting from 200 all the way to 250. So we have to multiply for us to get frequency. Remember the formula here, a class length of 50, and a frequency density of 0.12. That gives us exactly 6. The next class is starting from 250 all the way to 400, according to the graph, all the way to 400. So you see from 400 back to 250, we have 150. So the class length is 150, and we multiply it by height of 0.08. This gives us exactly 12 as the frequency in that class. Yeah, 12 as the frequency in that class. Then the other one is from 400, according to the graph, from 400 all the way to 600. All the way to 600. You see there the interval is 200. So 200 as the class length should be multiplied by 0.05 as the frequency density. 0.05. This gives us exactly 10 as the frequency. We have another class from 600 all the way to 800. 600 all the way to 800. Interval is 2. That class length of 200 should be multiplied by, 0.03. Yeah, the height there is 0.03. That's what you should be able to observe to give us 6, frequency of 6. Then from 800 finally to 850. 800 to 850. Yeah. 800 to 850. That gives an interval of 50. Then the height there is 0.04 or 05. That is a 50 times 0.04 to give us exactly 2. So that is it. So we have developed what we call a frequency distribution table. Frequency distribution table. What you're supposed to be very careful is, what you should be very careful with is you need to know that frequency, okay, that histograms are different. We have a histogram whereby class intervals are the same, and in such cases, you just have frequency against boundaries. But in a case like this, we are having frequency density against boundaries, meaning that we have used different intervals. Then with that now, we can extract the boundaries. And in this case, you remember that the boundaries are also the limits, because this looks like continuous data. Continuous data. This is continuous data. So that is how we're supposed to come up with the frequency distribution table. We can proceed to the other questions. Yeah, state the mode of frequency. Mode of frequency is 12. Mode of frequency should be the highest frequency recorded in a given set. The highest frequency in a given set. Some other times you'll be told to state the model class. You state the class bearing the highest frequency, but now we just want the frequency itself. Yeah, we want the frequency itself, which is exactly 12. The next, ladies and gentlemen, the next is calculate the mean number of students correct to the nearest whole number. So for us to get mean, we should talk about each class being represented by its own midpoint. Classes, respective midpoints. So midpoint of the first class, the class runs from, sorry, I'm trying to adjust my screen. Yeah, and remember to subscribe, ladies and gentlemen. I know there are those who are joining us late, others are joining us for the first time. Please subscribe to this platform. You are most welcome to Shifting Grades Online School. Look at this. Between 100 and 200, the midpoint is 150. So we write 150. Then now we're supposed to come up with fx, each frequency multiplied by the midpoint. So that gives us 4 by 150, 600. The next should be, okay, we can say limits added divided by 2. 100 plus 200 over 2. So 200 plus 250, then we divide by 2, we get 225. Then we multiply by 6. That gives us 1350. The next should be 250 plus 400. Then we divide by 2. That gives 325. 325 times 12, 3900. Then the next should be the midpoint of 400 plus 600. We divide by 2. We get 500. When this is multiplied by 10, it becomes 5,000. Then we are having 600 plus 800. We divide by 2. That gives 700 as the midpoint. We multiply it by 6. We get 4200. And finally, we have 800 to 850. That gives 825 as the midpoint. We multiply it by 2. We get 1650. Yeah, 1650 like that. Get 1650. Now we can talk about now the addition of fx, total fx. You know, we are finding mean. So total fx is when we add all this. This is supposed to give us 16,700. 16,700. Then for us to find what we are calling mean, we are also supposed to know the number of schools here. We divide by the number of schools. These are the total students estimated. Now we find cumulative frequency. That will give us the total number of schools here. The first frequency is 4. We add to the next, which is 6. So we get 10. We add to the next, which is 12. We get 22. We add to the next, which is 10. We get 32. We add to 6. We get 38. and we add to 2, we get 40 that way. So those are the cumulative frequencies. Those are the cumulative frequencies, and they have given us the total number of schools. So now we'll say mean. Mean is usually found by summation of fx divided by summation of f. 16,700 out of 40. So when I take 16,700 and I divide by 40, I'm getting 417.5, but we've been advised to the nearest whole number. So this becomes 418. Yeah, 418. There is something else that we are finding in part D. In part D, we are finding the median. So how do you find the median? For you to find the median, we are supposed to first establish the median class. We establish the median class. How do we establish the median class? We establish the median class by taking half of the total frequencies, which is giving us 20. Then now, the 20th school. Where is the 20th school? Because this is data from 40 schools. So the median number of students is supposed to be the number of the students in the 20th school. So where is the 20th school? We follow the cumulative frequency column. So we have 20, we have 10, then we have 22. That means the 20th is accommodated in this particular class, and it becomes our median class. This is our median class. That's our median class. Now with median class, we're supposed to calculate now median using the formula. Median equals to lower class boundary plus total frequency over 2 minus cumulative frequency before the median class. Then we divide by frequency of the median class. Everything here times the class width of the median class. So to substitute this, we go to the class and we get the lower boundary. So the lower boundary is 250. Then we add 40 over 2 minus cumulative frequency before the median class, which is the 10 out of frequency of this median class. Frequency of the median class is 12. Then times the class interval, class width. The class width, this is from from 250 to 400. That is 150. That way. 250 plus. So I'm taking 40 over 2, which is 20 minus 10, giving us 10 times 150 out of 12. That gives 125. When this is added to 250, we get 375. So the median is 375. And in part C, we are advised to find or to calculate the difference between the mean and the median. So the mean was 418. The median is 375. This differs by what? 43. Yeah, this is 418. So we get 43. So we have fully responded to that particular question from statistics. It's good for you to know that statistical graphs are becoming a very common area, and naturally, statistics do not miss in a national exam. Kcse has never lacked statistics, so kindly remain equipped in statistics. Please remain equipped in statistics. All right, number 21 now. The boundaries PQ, QR, RS, and SP of a range are straight lines such that Q is 16 kilometers on a bearing of 40 from P, then R is due south. R is due south of Q and east of P. and S is 12 kilometers on a bearing of 120 from R. Those are the information about these particular boundaries of a given range. What more do we know about this? We are told now using a scale of 1 centimeter for 2 kilometers to show the above information in a scale drawing. So we are supposed to begin from which point? The first instruction says Q16 on a bearing of 0.40 from P. So P becomes our initial point in this information. If it's our initial point, then we need to come up with P. We need to come up with P first. So this is our point P. Then from P, we are supposed to measure an angle of 40. Bearing of 0.40, that's a true bearing, meaning that it should be measured from the north and in the clockwise direction. Strictly from the north, clockwise direction. From the north and in the clockwise direction. So I measure 40 and I produce a line. We measure 40 and we produce a line. Yeah, like that. Then now there is a distance that you're supposed to measure at that point. After just the measurement of 40 degrees, what else are we supposed to consider? That the distance to point Q is 16. Then 16 kilometers should be represented by 8 kilometers according to the scale. So we divide 16 by 2 because each centimeter represents 2 kilometers. Then 16 kilometers will be represented by 8 centimeters. So we do 8 centimeters, we make an arc. We make an arc like that. Then we are supposed to raise a compass at that particular point. So I would advise my learners and followers to ensure that they measure another acute angle of 40 at the point up there. You'll get a north, which is you'll get a north which is very parallel to the first north. And that is the secret of being very accurate when it comes to bearings and distances. So for you to be very accurate, just ensure that you raise another compass there, which is very parallel to the first one by transferring the acute angle to a point like that. This becomes our Q. That's our point Q. More instructions. What are more instructions saying? More instructions say this, that R is due south of Q and due east of P. So due south of Q means from Q we just move downwards. Then when we say due east of P, then at P we move towards the right. It should be so horizontal, very horizontal. Now the intersection of those two instructions give us our point R. That's our point R. The intersection of south from Q and east from P. So they are intersecting at R. Then after that, we check more instruction about S. Where is S? S is a 12 centimeters to be represented by 6 kilometers. 12 kilometers to be represented by 6 centimeters on a bearing of 120 from R. So from R, we talk about a bearing of 120. We talk about a bearing of 120. That's a true bearing. It should be from the north in the clockwise direction. From the north in the clockwise direction. 120. So I produce that. Yeah, that way. And now we talk about 6. Distance of 6 centimeters. Then because we are leaving 60 at this point, to measure 120, we left 60 at that point. We can have 60 on the other side. We can have 60 on the other side. 60 on the other side enables us to raise a very perpendicular north. Very perpendicular north. Yeah. Very perpendicular north. So this becomes our point S that way. We have the 4 places now well described. After representing them now, what else do we do? Remember, we can complete to get the shape. We can complete all this to get the shape. So we can join Q and, okay, P and, we can join P and S. P and S can be joined so that we have a complete figure. P and S properly joined. So that is it. We have our range well constructed. Boys and girls, let's know that scale drawing is a very simple and very encouraging area. From this, we can find a few bearings and distances. We are told from the scale drawing, determine the distance in kilometers between P and S. So from P and S, you transfer that distance to your ruler and you shall discover that it is 10.8 centimeters. So 10.8 centimeters should be multiplied by 2 to give us the distance in kilometers, which is 21.6 kilometers. It's good to know that a certain range is allowed when we are having 10.8, so either plus or minus 0.1. So this will be either the people with the 10.7 and the people with 10.9 will also be considered to have done the right thing. They'll be considered to have done the right thing. Therefore, when they convert that distance to kilometers, they will be right. So there's that allowance. Then let's check the other question, which is in part 2, the bearing of P from S. The bearing of P from S. Let's check that. P from S. So for us to measure the bearing of P from S, we can consider the true bearing, P from S. We are already having the line joining P and S. So we consider the angle from the north in the clockwise direction this way. That is the angle, the whole of it. The whole of that angle, and that becomes 286 degrees. Remember, there is an allowance of plus or minus a whole degree. So the people who will measure 285 and those who will measure 287 will also be considered to be within the range, the recommended range for a score. Yeah, that way. Then again, there is something that we're supposed to know, that we can measure the smaller angle because the type of bearing has not been specified. We can measure the smaller angle on this side from the north all the way to this point. This is going to be 74. That angle, the one I've indicated with green, 74. So we've measured the compass bearing now from the north, 74 degrees towards the west. North, 74 towards the west. That is an alternative way of expressing the bearing. Then something else that we have been told to work out in part C now is calculating the area of the ranch, PQRS in square kilometers. So we use the actual distances now. Yeah, we use the actual distances. So for us to use the actual distance, then we are supposed to use Okay, we can have the figures divided into several, like this can be 1, then 2 is this one. So the first triangle is half. Okay, you know the distances are not known, all of them. All the distances are not known. So we can check them. And first work out the distances. Let me work out the distances first. We can talk of just want to show you a very quick way of establishing the distances here. And I will use a different color. It should be square. So this is already 16. And the height there, the height from Q to R shall be, we can say, the cosine of 40. The cosine of 40, considering the 40 which is up here, cosine 40 shall be adjacent length, QR, out of hypotenuse 16. So we can get QR 16 cos 40, which is a 12.26. Yeah, that is the distance. This is 12.26 meters. Then for this other one, this is already 12. Is it meters or kilometers? Yeah, kilometers. 12 kilometers. Then from P to S, we are having a 21.6. Then the angle between them is known. Remember the whole angle there. This is a 60. This is 60. The whole of it is 74. So this is 14 degrees. So now we can say area 1 equals to half times 16 times 12.26, the sine of 40. So how do we get this? Half times 16 times 12.26 sine 40. This gives us 60.04 square kilometers, sorry. Area 2 shall be half times 12 times 21.6, the sine of 14. Yeah, the sine of 14 degrees. Half times 12 times 21.6, the sine of 14. This gives me 31.35. Then we can get the total area now, which is going to be 60.04 plus 31.35. This is going to be 91.39. kilometers squared. So that's how we find the area for the given shape. Thank you so much for following. Remember to subscribe and to share this platform with your friends. Thank you.